Point two, completing the square. We're going to be rewriting quadratic expressions in completed square form, and then we're going to be solving quadratic equations by completing the square. So it's a very helpful process. So let's just recall what a perfect square trinomial is. So we have a trinomial here. 1, 2, 3 terms is a trinomial. And a perfect square means that it can be factored into one set of parentheses squared. So in this perfect square trinomial, if I think about a number that multiplied by itself gives me 81 and added by itself gives me 18. So what I'm thinking is 9 times 9 gives me 81. And I also know that 9 plus 9 equals 18. Okay, so 9 is the magic number here, which means it's a positive 9. So I have x plus 9 squared. That's my perfect square trinomial factored form. In this perfect square trinomial, I'm looking for a number when multiplied by itself gives me 100 and added together is negative 20. So I'm thinking that is negative 10 times negative 10, because that would give me a positive 100. And then if I added a negative 10 with itself, I'd get negative 20, just like in my trinomial. So the magic number here is negative 10, so it's x minus 10 squared. It's one perfect square. All right, so that is perfect square trinomial, and completing the square is when we don't quite have all of the expression that we need. For instance, we would just have an x squared plus a bx. So we're missing this term on the end if we just have x squared plus bx. So in order to complete it, it's a process. So what we need to do is we need to look at our b value. We need to divide it by 2. So cut b in half and then square it. Okay, if we do that, if we cut b in half and then square it, it's going to be a perfect square trinomial. So for instance, let's look at the b's here. If I cut 18 in half, I get 9, and then I square 9, I'm going to get 81. So it works there. If I cut negative 20 in half, I get negative 10. And if I square negative 10, I get 100. So it works there, and it works for every perfect square trinomial. So it's a rule. Okay, so if we're going to complete this, what we need to do is we need to add that number onto the end. So whatever b is divided by 2 square, add it to the end. So for instance here, what term should be added to x squared minus 8 to make it a perfect square trinomial? Well, you need to look at your middle term, the negative 8. You need to take half of it, and then you need to square it. Okay, so negative 8 divided by 2 would be negative 4. And negative 4 squared is 16. So the term that should be added to the end of this so that it's a perfect square trinomial is 16. Okay, because x squared minus 8x plus 16 is the same as x minus 4 squared. What term should be added to y squared minus 2y to make it a perfect square trinomial? So what we're looking at is the middle term, negative 2. Cut it in half and then square it. So if I cut it in half, I get negative 1. Negative 1 squared is just a 1. So we need to add 1 to the end. So y squared minus 2y plus 1. Now it's a perfect square trinomial, and it's going to be factored into y minus 1 squared. And the last one, looking at our b, I get 7 over 2 squared equals 49 over 4. Okay, so I need to add 49 over 4 to make this a perfect square trinomial. So u squared plus 7u plus 49 over 4 would be a perfect square trinomial. All right, solving equations by completing the square. So here we have x squared plus x, or 12x, equal to 0. So I don't quite have a perfect square trinomial. I don't have a trinomial at all. I need to add something to both sides. Remember, it's an equation, so I need to preserve the equality of this. So I need to look at my middle term, 12. And remember, I'm going to cut it in half and square it. That's the number that I want to add to both sides. Okay, and if you already know what that is, if you already know it's going to be 36, you don't have to write it in this form. Okay, so if you just wanted to write x squared plus 12x, and you're thinking, okay, this cut in half is 6, and if I square the 6, I get 36. That's good. That's fine. So 0 plus 36 would be 36. I just wrote this step so you could see where the 36 is coming from. All right, so now that I am in a perfect square trinomial on the left side, I want to factor this into the perfect square trinomial. So 6 is my magic number. 6 multiplied by itself would give me 36, and added by itself would give me 12. So it would be a positive 6 squared equal to 36. Now I'm going to use the square root property. So essentially I'm square rooting both sides. Square root and the square cancel. I'm left with x plus 6 equals plus or minus the square root of 36, which is 6. And now I need to just solve for x because it's an equation that I'm solving for. I need to find an x value. So I'm going to subtract 6 on both sides. And I get x equals a negative 6 plus 6. And x equals a negative 6 minus 6. Remember, because it's plus or minus. Okay, so negative 6 plus 6 would give me 0. And negative 6 minus 6 would give me negative 12. So I have two solutions for this quadratic equation. I'm going to complete the square when the leading coefficient is 1 again. So I want to get it into the form that my rule was in. My rule said it needs to be an x squared plus a bx and nothing else. So what I'm going to do is subtract this 7 over so that it looks to be in that form. 0 minus 7 is negative 7. Now that I have this on the left side, x squared minus 6x, I'm going to construct a perfect square. So I need to add something to both sides. And the number that I'm going to add is negative 6, this b term cut in half, so negative 3. And then I need to square it. So negative 3 times negative 3 would be 9. So I'm adding 9 to both sides. And if you're unsure what to add to both sides, think about the middle term divided by 2 and squared. Okay, now I'm in perfect square trinomial on the left, so I want to factor this. The magic number is negative 3. Negative 3 times itself would give you 9, and added together would be negative 6. So x minus 3 squared, negative 7 plus 9 is 2. Now, I want to get rid of the square, so I need to square root both sides. That way it cancels and leaves me with x minus 3. The square root property says that my answer would be plus or minus the square root of 2. And I need to solve for x here. So x equals 3 plus the square root of 2. And x equals 3 minus the square root of 2. If I type this into my calculator, I'm going to get a decimal answer. So this one would be 4.41. And this one would be 1.59. Again, I have two answers because it's a quadratic equation. Okay, what about when the leading coefficient is not 1? So for instance, here this leading coefficient is a 2. Again, I want to get it into a form that I can complete the square. So I need to move this 2 to the other side. So I'm going to add 2. That leaves me with 2x squared minus x equals 2. Now I just have an x squared and an x on the left side. Before I can construct a perfect square, I need this leading coefficient to be 1. So I have to get rid of the 2. If I'm going to divide it by 2, I have to divide the entire side, the entire left side and the entire right side. So think of this as each term being divided by 2. So 2x squared divided by 2 would just give me an x squared. Remember, this is a negative 1x divided by 2, so that'd give me a negative 1/2 x. And then over here, 2 divided by 2 would be 1. So let's construct a perfect square from this. Remember, I need to add something to both sides. And if you're unsure what to add, think about your middle term here, this negative 1/2. You need to cut it in half, and then you need to square it. So negative 1/2 divided by 2 would be negative 1/4. Negative 1/4 squared would be negative 1/16. So I'm adding, oh, sorry, not negative, positive 1/16. So I'm adding 1/16 to both sides. Now I'm going to put it in factored form. So I'd get an x minus 1/4 squared. 1/4, negative 1/4 multiplied would give me negative 1/6, or positive 1/16, and negative 1/4 added with negative 1/4 would give me negative 1/2. Over here, if I added these two, had a common denominator, I would change 1 to 16 over 16. So I'd add the numerators to get 17 and keep the denominators the same. So now I'm ready to do the square root property. So square root both sides. That would leave me with x minus 1/4. Over here I have the square root of 17, and then the square root of 16 in the bottom, which I know the square root of 16 is just a 4. And now I need to solve for x, so I'm going to add 1/4 to both sides. So I'm going to get two answers. Oh, remember the square root property, it's always plus or minus. Okay, so if you square root both sides, always just put plus or minus over here. I get 1/4, a positive 1/4 plus square root of 17 over 4. And I get 1/4 minus the square root of 17 over 4. So if I type that in my calculator, one of my answers, the first answer over here, I'd get 1.28. The other answer that I would get over here would be a negative 0.78. If you did not get that in your calculator, or I mean, at least get close. If you did not get close, call me over and I'll show you how to type that in your calculator. Okay, again, the leading coefficient is not 1 here. So first we need to get rid of the constant, so subtract 1. Zero minus 1 is negative 1. Then I need to get rid of my leading coefficient, so I'm going to divide everything by the leading coefficient. That would leave me with x squared minus 2x equals negative 1/3. Now that I have a coefficient of 1 in front, I'm ready to complete the square. So looking at negative 2, that x term, I need to cut it in half, and then I need to square. So that would give me negative 1 squared, so positive 1. So that's what I'm going to add to both sides. And I need to factor this into minus 1 squared. And negative 1/3 plus 1 would give me 2/3. Let's follow the square root property. So x minus 1 equals plus or minus the square root of 2 over the square root of 3. So after that comes rationalizing the denominator. We do not want a radical in the denominator. So I need to multiply by the denominator over itself. So square root of 3 over square root of 3. So in the top, remember we multiply things that have a house. So square root of 2 times the square root of 3 would be the square root of 6. And in the bottom, when I multiply them, I'd get the square root of 9. Well, I know the square root of 9 is just a 3. So now that I don't have a square root in the bottom, I'm ready to solve for x by adding 1. So I'm going to get x equals 1 plus the square root of 6 over 3. And x equals 1 minus the square root of 6 over 3. That gives me two answers. The first one is 1.82. The second one is 0.18. And the last one, a quadratic equation that may have complex solutions. Okay, so same steps here, but just keep in mind that we might have an I in our answer. So let's move over the constant by subtracting 8. 0 minus 8 is negative 8. Now I'm ready to construct the perfect square because it's just an x squared term and an x. In order to do that, look at your middle term. It's a negative 4. You need to cut it in half, so get negative 2, and then square it, which would be 4. That's what I'm going to add to both sides. So x squared minus 4x, add 4. Take your negative 8 and add 4. Now factor this into x minus 2 squared. Simplify this into negative 4. Square root property says square root both sides. The square and the square root are going to cancel, leaving you with x minus 2. Then you have the square root of negative 4. Well, the square root of negative 4 can, plus or minus the square root of negative 4, which can be written as the square root of 4 times the square root of negative 1. And we know that the square root of 4 is 2, and the square root of negative 1 is I. Now we're ready to solve by adding 2. So I get x equals 2 plus 2i, and x equals 2 minus 2i. Remember, I cannot combine those into 4i because this one has an I and this one doesn't. And I can't type that into my calculator, so there are my two solutions. There are complex solutions because part of them is real and part of them is not real. If you have any questions, please raise your hand and let me know.